This is the video introduction to Lesson 16, Resistors in Parallel, in the Mr. Circuit Basic Electronics Lab 2. In Lesson 15, we discussed resistors in series. In this lesson, number 16, we're going to discuss resistors in parallel. In series, the total resistance in the circuit was the sum of the resistance values. But when resistors are put in a parallel configuration, that is, the resistors are put side by side, we have to calculate the total resistance. If we put two 100 ohm resistors, R1 and R2, side by side, the equivalent resistance is less than 100 ohms. The way we get the equivalent value of these two resistors in parallel is by using this formula, R1 times R2 divided by the quantity R1 plus R2. So the calculation is 100 times 100 divided by the sum of 100 plus 100, giving us 10,000 divided by 200, which equals 50. So the total resistance in the circuit is 50 ohms. On page 16A of your lab manual, we show R1, a 100 ohm resistor, in parallel with R2, a 330 ohm resistor. What is the total resistance in this circuit? Use the formula R1 times R2 divided by the quantity of R1 plus R2. That gives us 100 times 330 divided by the sum of 100 plus 330. Or 33,000 divided by 430, and that gives us 76.744 ohms, or approximately 77 ohms. How much current will flow in this circuit? Using Ohm's law, we get I equals E divided by R, so I equals 9 divided by 77, therefore, I equals 0.117 amps. So we would have approximately 117 thousandths of an amp flowing in this circuit. At this point, I would like to say that many times in electronics, instead of saying 117 thousandths of an amp, we say 117 milliamps. So 117 milliamps is the same as saying 117 thousandths of an amp. If I were to say 30 milliamps, how would I say that using thousandths of an amp? I would say 30 thousandths of an amp. They are the same. By the way, the abbreviation for milliamps is a small letter M followed by a capital A. To give you some perspective, a typical portable transistor radio with audio volumes at normal hearing level would consume 30 milliamps of current per hour. A typical 9-volt alkaline battery has about 600 milliamp hours stored in it. If the radio consumes 30 milliamps per hour, how long will the battery last? About 20 hours of continuous use. That is, 600 milliamp hours divided by 30 milliamps is 20 hours. Here is another example of two resistors in parallel. R1 equals 1200 ohms and R2 equals 220 ohms. What is the total resistance in the circuit and how much current will flow? Using the formula R1 times R2 divided by the quantity of R1 plus R2, we get 1200 times 220 divided by the sum of 1200 plus 220, or 264,000 divided by 1420. That gives us 185.92 ohms is the total resistance in the circuit. How much is the current in this circuit? I equals E divided by R. I equals 9 divided by 185.92. Therefore, I equals 0.0484 amps, or rounding, we get 0.048 amps, or we can say 48 milliamps. Let's do one more example of two resistors in parallel. Here we have R1 equal to 100 ohms and R2 equal to 390 ohms. What is the total resistance in the circuit? Using formula R1 times R2 divided by the quantity R1 plus R2, we get 39,000 divided by 490, or 79.59 ohms. How many milliamps will flow in this circuit? Using Ohm's law, we get I equals E divided by R. I equals 9 divided by 79.59. Thus, I equals 0.113 amps, or 113 milliamps. That's it. You're now ready to finish this lesson by solving the 6 resistors in parallel problems on activity page 16B in your lab manual. When you've completed that, you're ready to go on to lesson number 17.